Hello and welcome to my online video. In this video, I will show you how to use CADdoctor, the universal tool for translating and fixing 3D CAD models. When you start CADdoctor, you will see this window. On the left are the Structure and Work tabs. The main viewing area is in the middle, and on top is a toolbar that looks like a typical Microsoft Windows application. The first thing you'll need to know is how to import or open a file in CADdoctor. To do this, click the blue arrow in the navigation panel. An import dialog box appears. Select the file type you want from the lower drop-down box. Then select the file you wish to import and click Open. Now that your file is open, you need to know how to position the model. To move the model left or right, press the right mouse button and drag. Rotate the model by holding the left mouse button while moving the mouse. Zoom in and out with the wheel. To center your model in the viewing screen, click the magnifying glass in the toolbar. If you would prefer to use other conventions for moving the model, click File, System Preferences, then choose View Operations in the dialog box. Then open the drop-down menu at the top. Here you will see a number of common CAD systems such as CATIA and Pro Engineer. You can pick one of these or customize your choices to match other systems such as SolidWorks or Solid Edge. Next, let's look at the Work tab. At the top you will see a drop-down menu with all the functions you can perform with CADdoctor, such as translation, manufacturing checks, simplification, and reverse engineering. For now, let's choose the translation option. To the right of the functional drop-down, there are two more boxes. One shows the input format of the model we opened. In this case, it's the CATIA V5 model. Below that is the Out drop-down menu. Opening the drop-down dialog, you can see the translation options supported by CADdoctor, including CATIA V4 and V5, Siemens NX, Pro E, SolidWorks, Solid Edge, Inventor, and many others. For now, I'll just choose Pro E. In the large box below the category list button, you can see a list of geometry defects that CADdoctor tests for both before and after translation. For example, it looks for edges used more than once, short curves, sliver faces, missing faces, and loops with self-intersections. If you select the gear button to the right of the category list button, a dialog will appear that enables you to customize the list of defects and the allowable values for gaps and other threshold values. Next, let's choose the Structure tab and expand the model structure tree. In this window, you can see the number of individual parts in the model, the number of solid bodies in each part, and any geometry that is dissociated from a solid. This display can be useful in diagnosing and correcting problems with models. Lastly, let's talk about the toolbar. Here you'll find commands that are common to many programs such as New Document, Open, Save, Undo, and Delete. The toolbar also has commands that are common to other types of CAD systems, including buttons for displaying cross sections, fitting the model to the graphics window, rotation, and fixing the point of rotation. The Axis Alignment button lets you choose an axis on which to view your model. This button allows you to change the viewing model from shade to wireframe. There's even a zebra mode tool, which paints the model with black and white reflectance lines that enable you to quickly pick out discontinuities in curvature. The Info button provides technical information about your model that most CAD systems won't tell you. Simply click Info, click on the part you want to find out more about, and then click the green check mark. You will see a window of information such as number of faces, edges, and vertices in the model. Click the red X when you're done. In our next tutorial, we'll show you how to find and correct geometry defects in your CAD models. These defects can not only inhibit translations but also applications that use CAD data, such as finite element analysis and numerically controlled milling.